we are ready to do a final check. Do a final check of the system folder. So which means we can go to the system and have final check if we define the contradict properly. The contradict is from latest time to end time. We don't need so many iterations. We just apply 200. The right interval we can use 20, and it looks good. And the FV scheme and FV solutions, I think we can directly copy from our examples. So the example is actually based in the if you remember, it's based in the home and tutorials. So that is tutorials, and we go to the heat transfer and simple form, and we just choose the FV schemes of the fluid and the solid. So the fluid, I will use air, so I can copy these two as our solution scheme and go back to the system. The system, I have domain 1, so I will copy and paste here. That is for the fluid. It should be working here as well. And for solid, I should have different FV schemes. So I can use the system folder. The porous is a solid, so I just use this as our solid FV scheme and FV solutions. So if I just have a quick look at it, which means it only gives the temperature or the energy. It will only solve the energy, if I remember, not here. So I think that is not what we want. So we go to this and find the solid. So these two are solid. So the CPU and fans are solid. So I will copy these two as my solid solver, which be more fit our purposes. So let's check again. Yeah, that's good, because it's only have the Laplacian schemes, and if I open the solutions, only solve the edge, which means only the energy. So I think it's good for us to go, and we go back to the OpenFOAM and the demo, and I think we are ready to run the CHT multi-region simple code. So we have an error here. So I run the OpenFOAM again. It indicates I still need to define the head file for the velocity. So let's go back to the domain 1, and the velocity, I didn't include the head files, so I will copy the head files for it as well. Remember, that's only for domain 0, so you need to define the rest for the domain 2. So I need to go back here, and it's domain 2 at this stage, right? So I need to go to the temperature. Again, it's domain 2, and it's temperature. So I use its temperature and the PRGH. So I will just copy this, copy all of this to the PRGH, and it will be the PRGH. So PRGH, and finally it's a pressure. So pressure. So I include or add all the head files, and I will run this CHT multi-region simple form again. So the error indicated here is mainly from the head file of the pressure of domain 0, if you remember, we just copy the main boundaries, but we didn't indicate any head file. So if I open 0 folder and go to the domain 0 and open P again, I'll find there's only the main definitions, but without any head indication. So that's why it happens. So what I can do is I just copy the header here. I indicate it is pressure definition, and of course, because I would imagine it will happen for all this, right? So I can copy all this to this header, and I just indicate it's RJH, and also for the temperature. So also for the temperature, and I just indicate is temperature here, and about velocity is not exactly if you see here, they are only have the class of dictionary, and also have the scalar. And for the velocity, they usually need to define a different ones. But anyway, I will just run it again. I run the command again, and it's another error here indicating cannot find the file OpenFOAM. For the solid region, we have no thermophysical properties defined, and we have the thermophysical defined for both domain 0 and domain 2. It clearly says, so I will copy this, but then I go to the solid. Yeah, I didn't define any thermophysical properties for the solid. That's why I need to define it, and I will go back to my slide. I will say there will be some definition for the solid. So I need to open this and change it into the solid properties. So I just copy and paste this to my files. Should give me all the physical properties properly, and it will be okay to have another run trial. So we have another run scene head problem when reading the header for project object P in the solid. Again, this is a header file, right? So the header file is not found for the solid region. So we do both fluid regions, but not for the solid. So again, I need to add the header files here. So indicating it's 0 solid, it's P, right? And also I need the temperature to with this header file too, and the header file and the object is T. So hopefully that solves error. So the final solving process, if you can say, is really about debugging all these files we produced according to the warnings. Actually, I have another warning which figure out later will give me some errors when I define the solid size of the solid region, so the temperature for the solid region, which means the solid have two sides. These should be insulated. I previously used the calculated, but it should be a 0 heat flux at that stage. So I need to change this according to the solid. Actually, I need to change this. I can use couple method and solid thermal. I copied from the fluid, but now I change it solid thermal, and now it gave me the correct boundaries definition, and I'm ready to run the command again. I can just copy the previous, and if I double check, as I said here, double check all the latest time, double check all the settings for control dictionary. So I use 200 and 200 steps, and with right interval of 20, that will give me 10 intervals. So I will have a quick check. Yeah, it's running now, and it should give us the results very soon. And I will open the I can firstly check the folder. So check the folder, which means the demo folder. I have all these files relevant to my time results, right? So after figuring out all the errors, so the error is mainly from the header file, which not the physical error, is only error or warning from the OpenFOAM file structures. We just directly and copy them and to solve the problem. And then I can open the preview and load all the results by clicking the refresh and demo foam. And remember, I have 3 domains, so I need to click all the 3 domains here, and it will give me some results. It will auto download all the results to this, and I'm ready to check all the results. So the results is from the preview. It can produce a temperature and velocity. Let's find the temperature first. So temperature for all this, and this is a very initial, and then we go to the very last. So that is last temperature definitions. So we say this is the inlet, this is outlet, this is the inlet of water, this is inlet of air. So the air is cooled down to some extent, and the water become warmer when during travel to another direction. So we remember we only use 200 steps. Now we increase the step to 500, and also we use the interval to be a bit larger, so another 10 steps. So I will still run, so it should give me the final time from 200 to 500 with right interval of 50. Let me check again. Yes, so all these files means all the results have been writing, and what I need to do is just to refresh again, and all the files will be downloaded here, right? So we go to the final 500. I would say the temperature has been cooled down, right? Cooled down further, and the water, no big change, but we can definitely see the temperature gradient, the air from high to low, and water a bit increase from the low to the higher, but not too much. And it's very difficult to check how the solid transfer, but we would say the solid has a very high heat conduction coefficient or heat conductivity, so there's no big difference between the interfaces. And of course, if we can check velocity, we can have the results as well, and it's more explicitly give us a clue that the solid is between the air and the water. So it's a black space is the solid region, which is no temperature, no velocity, but the velocity of the air and the water can be very obviously seen. So this is a quick demonstration of all these settings for the conjugate heat transfer from scratch. I believe you have some understanding through this simple example.